Hey everyone, we are just going to review today. We are going to review days 1 through 5, and the reason why we're doing that is 1, I'm not there, and 2, because looking at your skills check, a lot of you did really well, but there were certain points that I feel like we need to review because we do have a test coming up on Thursday for part 1 of chapter 4. Tomorrow we will learn something new, and then we'll review on Wednesday, and then we have that test on Thursday. So let's go ahead and do one more round of review for what you guys did on Friday, which was the skills check. I will point out certain aspects that I feel like you really needed to get some more review on, or where we had the most errors. So given the function and its graph, identify the following characteristics. So right away, looking at this function, we can see that it's concave down because the arrows are pointing down. So I know it's concave down. Our vertex is right there in the middle. So our vertex is right here at -1, 4. You always put the x value first and then the y. So we have vertex -1, 4, which I saw some mistakes on the skills check where we had some people switch it and had 4, -1. So make sure you always list that x value first. It's super important to know your vertex because you can pretty much use it to guide you for the remaining of these questions. So your axis of symmetry is always at the x value of your vertex. So we have x equals -1. Now on the skills check, a lot of you put -1, and that's great that you know that. But please know that your axis of symmetry is a line. So if you just say -1, I really don't know what you mean. But that x equals -1, which is right here in purple, is that line down the middle of the x value of your vertex. So x equals -1 is my axis of symmetry. You can put a little dotted line there if you want. That'll also help you with your interval of increase and decrease. But let's take a look at your y-intercept. Your y-intercept is where it crosses this y-axis right here. And your y-axis is at, your y-intercept right here, your y-intercept is going to be at 0, 3, because you don't go left or right anything, but you do go up 3. So we go left, right, 0, and up 3, which is what that means on the coordinate plane. Your x-intercepts, we have 2 of them in this situation. We have one here and one here. So these are my x-intercepts, and they are at -3, 0, and 1, 0. Again, we go left 3, so -3, and we don't go up or down anything. That's why it's -3, 0. The parabola has a max or min, so whenever you are concave down, you are going to have a max. And that means that there is no value higher than that y value of your vertex. So if you take a look here, there's no value higher than 4. There's nothing, there's no function above 4. So the value is 4, and it's located at the x value of your vertex, which is -1. So you can see that the vertex has already helped us out with the axis of symmetry and has helped us out right here for the max or min. So knowing what your vertex is one of the biggest points of parabolas, and making sure that you understand where that's at. Your domain for all parabolas is all real numbers, which is -infinity to +infinity. Make sure we write the interval and not just write all real numbers. Your range goes from bottom to top. Now your range, again, is going to look at your vertex. The range always means your y. So your range is always your y values. And we're going to start at -infinity because there is function here. You don't have to highlight this, but there is function, there is function, there is function, and we stop at 4, which is the y value. And that's why I have -infinity and we stop at 4. And we have to close bracket it because that means that we're including that number into our interval. Interval of increase and decrease. This is where I saw one of the most common errors on the skills check, so make sure we're following along for this part. I'm going to try something a little different. Instead of highlighting the graph, I'm going to highlight I'm going to highlight the x-axis. So I always start at -infinity and I go to positive. Now on the left side of the graph, I am increasing. So if you see here, the value of this function is increasing, 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 then I hit a wall. And that wall is the axis of symmetry. And that's why we go from -infinity until I hit that wall of -1. Then I'm going to pick back up at -1 here at that axis of symmetry, And I'm going to keep going until I go to positive infinity. So I have -1 to positive infinity. Again, because you are decreasing, the y values are decreasing as x gets bigger. Okay, so as x gets bigger, our y values are decreasing is what you're describing. Okay, so you're always using that x value of your vertex or your axis of symmetry. That's why it's super important to understand where your vertex is. And if you notice here, everything highlighted in yellow, you could have used for your from your vertex. So make sure that you get that vertex right and you understand what the vertex is. All right, this one. Your vertex, when you're given a function, this is in vertex form, is always going to be this h and this k value. So that h value is a +4 because in our original formula, it is already negative, and then a +1. So that's where our vertex is for up 1. That's our vertex. And you can already tell from right here in green, we're going to be concave down. So we know it's going to look something like this. Okay, and you can wait to answer some of these questions until you put it on the graph. That's fine. But knowing that it's concave down, we're going to have a max, which means there's no higher value than this. So this would be a max value. And where is it at? It's always going to be at that y value of the vertex, and it's located at the x value of the vertex. So describe all transformations from the parent function f of x. So we have vertical dilation. That just means stretch or compress, and you might not have one all the time. So you can circle none if that's true, but in this situation, in blue, we are going to be stretching because it's bigger than 1. Remember, if I multiply you by 2, you're going to get a lot taller and a lot skinnier. So it's a factor of 2. So stretch by 2. Vertical translation, which just means up or down. And if you take a look here in purple, we're moving up 1. So we're going to go up 1. Horizontal translation is just that x-axis or left-right. And that's going to be this yellow here. And it looks like we are going to be moving right. And that makes sense because when you look at your vertex for 1, you'd be going right 4. So 4 units. And is it reflecting over the x-axis? It is because of what's in green. The negative right next to the equal sign means that we're reflecting over the x-axis, which means we're concave down. So here's when you want to get out your graphing calculator. If you don't have one, make sure you go grab one and do this with me. Don't just wait for me to do it because that's not going to help you. Okay, here's my graphing calculator. All right, so I'm going to go ahead and plug it in. So I have negative, which is down here in red, 2 parentheses x minus 4 all squared plus 1. Go ahead and press graph just to see that you know what it looks like. And you can confirm right here is where your vertex is, and you said it was at 4, 1, which is true. But now we want to get some points on our graph, so I'm going to draw my XY table. And I always like to put that vertex in the middle, so 4, 1. That's why I like to do that, because then you have a nice and pretty graph and 2 above and 2 below. So I press second, which is the blue button, graph, and there's my table. You can scroll up or down until you get the points you want if you don't have it right away. So I'm going to go ahead and fill that in. I have 2 and 3 goes here, and then 5 and 6. And when you look here, when we're doing 3, our y value is -1, and when we are our x value is 2, we have -7, which mirrors on the other side. Okay? So let's go back to our graph and go ahead and put that in. So I have 3 down 1, which is somewhere around there, and then I have 5 down 1, which is somewhere around there. They're symmetric. Sorry, I switched that on you. I have 3, right 3 down 1, and right 5 down 1. And then I have right 6 down 7, which is somewhere around here. And then I have right 2 down 7 as well. And it's going to look something like this. And you can confirm it. So if you want to draw this out before you answer the questions A, B, and C, you can. It might help you to draw it out first. Because look, it looks like, because this is where our original point is in our parabola. If you're looking at your normal graph, let's just pretend to draw this in. This is my parent function, so you kind of know what's going on. What happened? I moved right and I moved up. And then I also, reflected down so you can see, what we did. That's what it means to transform something. Okay, this one, I feel like a lot of people did not do well on this, so make sure we're paying attention here. Again, just knowing what the vertex form is telling you. This A value is telling you if you're stretching or compressing. The H value is telling you if you're moving left or right. And the K value is telling you up or down. So the function has a vertical stretch by a factor of 3. So that's that A value out in front. So I'm going to go ahead and put that 3 all the way out in front. And you can kind of set up your function just by doing that, because everything else should be in there. That X always has to be there. So in blue, we're moving left 5 units. So that's going to be left 5. When we move left 5, that really just means that's going to be a negative 5 when you move left, which changes this to a positive 5. And that, again, is why when we have plus 5 in our vertex formula, we are moving left. And then we have down 2. So down 2 would be that negative 2, and we're done. I want to take the time. So that was basically what you were tested on Friday, just to see where you were on your skills check. So hopefully you were able to see that. If I did not show it to you, I will show it to you tomorrow. But this is the newer part, and I want to make sure we went over because there were some people that were confused with it. Let's write out our formula. F of x is equal to a x minus h all squared plus k. And that hk is your vertex, and then your f of x is going to be your point. So let's go ahead and plug it in. Remember, we're solving for a to see if we're stretching or compressing. That's going to help us out when we're writing this function. So let's go ahead and plug it in. So that f of x value is 30. So I'm going to plug that in. We don't know a. We want to solve for a. I'm going to leave it alone. But we know the x value. The x value is negative 2, so I'm going to plug that in. Bring down your minus sign. The h value in blue is a negative 1, so it's going to change it to positive and go to 1 because it's originally negative. So that was the h value. Then we have the last part here, which is the k value. So squared minus 5 minus 5. Okay, and that was that k value. So now all you're going to do is you're going to solve for a. And how do we do that? Always do parentheses first, just like PEMDAS says. Please excuse my dear Aunt Sally. You do your parentheses first. So we have negative 2 plus 1, which is a negative 1, and then all squared. So we have negative 1 squared, which is negative 1 times negative 1, which ends up being a positive 1. So again, we're solving for a. That 1 that we just determined, because negative 2 plus 1 is negative 1 squared, is 1. You could put a 1 here if you want, if that helps you out. I don't think it's necessary, so I'm not going to write it. My last and final step is to add 5 to both sides. Gone. And my a value is equal to 35. Now think about that for a second. The a value in vertex form is always going to tell you if you're stretching or compressing. In this situation, we're going to be stretching because it's bigger than 1. So whenever the a value is bigger than 1, which in this situation is 35, we're going to be stretching. So this means we're stretching. So knowing what you're doing is going to help you understand the math a little bit better. So the last and final step is just to plug it in. F of x. Again, you have to leave f of x and x alone when you're plugging it back into the formula, because otherwise you can't put it in your graphing calculator. We want a function that we can graph. So we're going to go ahead and take that 35 and we're going to put it out in front because that's our vertex form right here. We're using that. And then you want to write everything else basically the same, leaving your x alone. I'm going to take this part right here and just basically copy it down. So plus 1 all squared minus 5, and we're done. And again, knowing you can always check it. This is in vertex form. So this should be my vertex, negative 1, negative 5. And if you take a look here, that's what it was. Okay, so from this point forward, you can go ahead and show that you finished your notes and then start on your homework, which is almost identical to what we just did, to make sure that you're mastering it. And then we're learning one more thing tomorrow, and we're testing on Friday. And I feel like we're going to have really good scores because the skill check was great. So I hope you have a great day and be kind to one another.